Good morning all. You'll probably recognize my little watt meter here. What I made myself out of an Arduino Pro Mini, a little OLED display and the INA 219 board. And I'm powering it from a 9-volt battery. I got these from the pound shop, these PowerCell ones. I think they're either zinc carbon or zinc chloride. What's certainly the case is that they're absolute rubbish, because they only seem to last about, well, I don't know, 10 minutes or something on this little watt meter. Now, this thing's got the CPU running at 16 megahertz, which is unnecessarily fast, really. So, I mean, maybe it does draw a fair amount of current, but these are just hopeless. Let's plug one in just briefly. Now, I know that one of these has gone low, so this thing locked up while I was doing some experiments, but the other one is brand new. So what I was thinking of doing today, let's just power that up. You can see the red light comes on the back of the board, and that's reading watts. But the trouble is, when it locks up, you can't really see it. It's just the number goes static, and then all your results go haywire. So what I thought I'd do today is actually see if I can test the capacity of these zinc something ultra heavy duty, or is it super heavy duty, it says there, these super heavy duty 9-volt batteries, and compare them with these, which I'll try and bring in. These are nickel metal hydride. I've charged these top two, although I'm not sure they've charged properly. They're not very good, those Digimax ones, but these Vapex Instants do seem to be pretty good. They're not charged yet, they're still on red, so we're charging these up. They actually do say 200 milliamp hours on them, so we can check whether their capacity does reach that 200 milliamp hours, and compare it with these rubbish cells. And to do these measurements, I'm going to use this. It's the 60 watt DC, electronic DC load. It's actually got a model number down there. I'll try and get in on that. Oh, there it is. It's a ZU ZHIYU. Where's my torch? There it is. It's a ZPB30A1 electronic DC load, and it's also got a second mode, which is battery discharge mode, where it will measure the capacity, and this one is a V2.7. I presume that's the firmware version. So the first thing we do is power this up. Now, unfortunately, the 12 volts I'm currently using to charge these batteries, I now need for this. Why are all the lights still on this thing? It looks like it's being powered by the 9-volt batteries. Right, so let's plug that in. Now, if you hold down the run button while you plug it in and wait for the self-test, you get two modes, two function modes. You've got function 1, which I think is just electronic DC load with a low voltage cutoff. But function 2 is electronic DC load with a low voltage cutoff, but it also measures amp hours and watt hours. So that's the battery discharge mode. So I want function 2, I want the beeper on, and it's ready to go. Now, I've set the low voltage limit at 6 volts. I kind of figured that a 9-volt battery, once it gets down to 6 volts, is pretty much depleted. And I'm going to run this at 0.2 amps. That's really interesting that first digit looks really weird on here. It doesn't look weird to the naked eye. So that's 200 milliamps, because these were 200 milliamp hours. That's actually the lowest value you can set on this. The minimum is 200 milliamps. So 200 milliamps, that should give these a 1 hour runtime on this unit. So that's ready to go. I just need to wait for these things to charge up. I suppose I can do the discharge tests of these two. I mean, it's possible that I could do those live on camera, because I don't think they're going to last very long down to 6 volts at 200 milliamps. Now, I suppose I should mark these so I don't get in a mess. I don't know which one is the fully charged one, the one I haven't used, fresh out of the pack, and which one is the one that I have used and appears to be pretty much dead. But I'll mark these 1 and 2, and I'll just now put them on test, starting with this one, number 1. Right, let's try 9-volt battery number 1. Let's set that going. So it's on J5 2-wire mode. There is a 4-wire mode. That should be telling me amp hours. Watt hours is 0.002. It's got already down to 6.5 volts, so this isn't going to last very long. It's not really clocked up any amp hours, or milliamp hours that is actually, isn't it, at all. But it is at least running. But at 200 milliamps, oh, it's almost hit 6 volts now. So that one I don't think is going to be is going to give much of a result. Right, well, it's come up at 1 milliamp hour. So that's just terrible. 1 milliamp hour. Let's shut that thing up. At actually, I could write that on it. At 200 milliamps. Now, just before I run the second one, let's have a look at some data here. This shows the typical capacity in milliamp hours of primary alkalines at 550, zinc carbons at 400. It doesn't have zinc chloride here, but that seems ever so high for a zinc carbon. That would have to be a high quality zinc carbon. And the lithium, of course, is a totally different ball game. Now, the rechargeables, the secondary batteries, or using secondary cells, nickel metal hydride comes in at between 175 and 300. Well, mine are actually marked 200 milliamp hours, so I'm hoping to get close to that figure. There's some nice pictures here as well of the zinc carbon and the alkaline, and alkaline using cylindrical cells, 6 cylindrical cells, or 6 sort of rectangular disc type cells, the different constructions. So really the zinc carbon should outperform the nickel metal hydride. That's what this appears to say. Okay, so I've written 1 milliamp hour on that number 1 battery. Now number 2. So this one should be better if it's the one that's not been used at all. Let's give it a try. Well, that's immediately plummeted to 6 volts. These things have a terribly high, I mean 0, nothing at all in that cell in that battery down to 6 volts. That's just awful. Now, I didn't really want to do this because this is a brand new GP Ultra. Actually, I've just started peeling this off camera, which was a bit stupid, but this was completely brand new, sealed, 2 for £3. So these are £1.50 each. Didn't really want to run this one out completely unnecessarily, but I'm kind of intrigued now just to see what voltage this sits at 200 milliamps. This is obviously a branded battery and should be a fair bit better than these rubbishy pound shot ones. So let's hook this up and just sort of start this test going. And if I feel like I'm happy to let it drain right down, well then I will. But I'm interested in the voltage initially that this thing sits at. So let's start that thing running. And, you know, that's so much better, isn't it? 8.8 volts that was sitting at. 8.75. So it probably isn't necessary to run this all the way down to nothing, because you can see immediately that this doesn't have the problem that these awful batteries have. That's hanging in quite nicely. Amp hours, it's clocked up 1 milliamp hour so far. Yeah, I don't think I can justify just draining this for no good reason. I'm happy to drain the nickel metal hydrides, these ones here in the charger, because of course I can recharge them, but it just seems a waste to drain that one down, so I don't think I will. But I mean, you can see immediately that this is going to clock up, well, probably something in the order of these figures here. A decent alkaline, it says, should have 550 milliamp hours. Perhaps it would. Right, it's another day, but I've got my Vapex instance now charged. These were messing me about a bit. I don't think they'd been used for a while, and they were only registering a very low charge, and the battery charger was saying they were full and all that sort of stuff. But I think these are now probably properly full. So let's try measuring the capacity at 200 milliamps of one of these Vapex instants. Right, this is good. I'm plugging this thing in and it's immediately coming up error 6. What exactly is error 6? I must admit, I do have a suspicion about this. The sun has sort of come out a bit, and you can see there that the voltage of the batteries that I'm using to power this thing is currently up at 14.4 because the charge controller has a short period in sort of boost mode, and I've got a feeling maybe it's over voltage for this unit. I mean, I could wait until that drops to 13.5, which it will do at some point. Yeah, I think that must be it. Yeah, that does seem to be it. Error 6, power supply voltage too low or too high. Minimum is 12 volts at 0.5 amps. Well, I've just been outside and bodged it. I've disconnected my solar panel. We're now down to 13.4 volts. Let's try it again. Let's do that right now. Yeah, that looks better. Right, so with this nickel metal hydride battery connected, let's see what we get. Let's start this running. So that's 7.8 volts. So that is a bit low. Now I've got a feeling these aren't 9-volt batteries. I've got a feeling these are 8.4. In fact, on the back of this charger, it says that it can charge only the 7.2 volt, 8.4 volt, or 9.6 volt nickel metal hydride rechargeable batteries. Now I've got a feeling 8.4 is 6 lots of 7.2 is 6 lots of 1.2. So that must be a 7-cell battery, and this must be an 8-cell battery. So I think this is the 7-cell, 8.4 volt nominal. Does it say on it? No, it doesn't. But anyway, the voltage on that, how's that holding up? 7.58. So I mean, that's holding up pretty well. That's 2 milliamp hours. That looks like it's going to stay the course. Better than these. Stay the course in the same way that the alkaline one did, and in the way that these two simply can't manage. I'll leave this running for a little while. Now, one thing did occur to me. Maybe the problem with these cells is more to do with internal resistance than actual capacity. And maybe this 200 milliamps is a bit too aggressive for these cells based on their internal resistance. In fact, if we calculate the internal resistance of this thing, at a nominal 9 volts, it's doing 0.2 of an amp. So R equals V over I. So that's 9 divided by 0.2. So that's 9 times 5, isn't it? So that's 45 ohms. 5 nines are 45. Yeah, so this is presenting a load to a 9 volt supply of about 45 ohms. Now, interestingly, I was looking around at the internal resistance of various 9-volt batteries, and you can see that the zinc carbon is noted here as being 35 ohms. 35 ohms, that's completely mad for zinc carbon, whereas alkaline, 9-volt alkaline is just 1 to 2 ohms. So, I mean, there's a massive, if this is true, this has come from learning about electronics. This was incidentally just a Google search for zinc carbon internal resistance. But there's a massive difference between the internal resistance of presumably nickel metal hydrides, that's not actually on this list, and alkalines, and totally different are the zinc carbons. So maybe that's where the problem lies. And in fact, if this thing has a resistance of approximately 45 ohms, and these have an internal resistance of 35 ohms, then really what we're getting is that this thing is going to pull the battery's apparent output voltage down to almost half its nominal voltage. So it's not surprising that these duck down very low very quickly. So maybe there's actually a fair bit of capacity left in these, but you can't pull it out at 200 milliamps. And because this unit has a minimum current setting of 200 milliamps, there's not much I can do about that. How are we doing? We've got 7.2 volts on this thing, and it's delivered 13 milliamp hours so far. Now, I spent virtually the whole of yesterday trying to find what I thought I'd bought, which is a battery internal resistance checker. I found this, but I think this is just another, it's actually got a similar number, hasn't it? A ZB2L3. This is just a sort of low-cost version of this battery capacity checker. This, I think, is a battery capacity checker, but just uses a fixed resistance rather than a constant current load to measure the battery capacity. But I cannot find the thing which says it's an internal resistance checker, because I wanted to confirm whether this 35 ohms value is correct for this sort of battery. But I've thought of another way of doing it. So I'm just going to disconnect all this. But yeah, that battery's holding out all right. 7.1 volts still across it. 20 milliamp hours. I'm not sure whether it's going to deliver the full 200, but maybe the curve is a bit of a drop and then a flat and then another drop at the end. Batteries tend to do that. So I'm going to pack this away now and see if I can measure the internal resistance of these batteries. So what I'm going to do is just take my multimeter and use these croc clip connectors to connect onto the positive and negative of the battery. I'm going to use the one that had the better response. These are supposedly both flat now, but if this is an internal resistance problem, then that DC load, that capacity checker, wouldn't have emptied this battery anywhere near the full amount. It just would have pulled its voltage down because of its resistance and the resistance in here. So this should be still a good battery. Let's give that a try. And yeah, that's still got about 9.5 volts across there. So certainly there seems to be some voltage across here, the full voltage, really. Now, the way I'm going to do this internal resistance check is I'm going to take this. It's a 1K resistor. Now, let me turn that around. It's brown, black, red. Might have a job seeing that, but that's what it is. It's a 1K resistor. And put it across this battery and measure the voltage with this. Oh, that's going to be tricky, isn't it? Yes, that's going to be tricky. Okay, still 9.5 volts on the battery. Sit in there. Ah, there we are. So let's just let that settle. About 9.15 would that be? It's going to climb a little bit higher. Yeah, let's say about 9.15 with the resistor. And without the resistor, I'm quite certain that will climb back to its original 9.5 volts. Let's see if we can work out the internal resistance of this battery from those results. So what we've got here is the battery with its internal resistance. Let's call that Ri. And we put that on the multimeter. Oh, let's draw that as a circle with a little arrow. Without a resistor across the battery initially. No, the battery is this section here. Let's draw that as a dotted line because the internal resistance is internal to that battery. So that's where we were measuring the 9.5 volts. Then I put a resistor here, and this was the 1K resistor. And with that in place, we were measuring 9.15 volts. Yes, that's gone back to 9.5 volts now. So with that 1K resistor in circuit, the output voltage, which we measured at 9.15. So V equals I, no, hang on a second. This is a potential divider. So the output voltage is the 1K part out of the total resistance, which is 1K plus Ri, times the actual battery voltage, which we're measuring without this 1K resistor at 9.5 volts. So it's that. And I want this, Ri. Now I should be able to get that because all the rest of this is numbers. So let's just rearrange everything and see if I can get Ri. So it'll be Ri plus 1000 is 1000 times 9.5 over 9.15. So I just need to calculate that, and that gives me Ri. Right, so 1000, switching it on would help. 1000 times 9.5. That gives me that, divided by 9.15, divided by 9.15, gives me that. And now I've got to subtract that 1000, move that to the other side and subtract it. So minus 1000 equals 38. So what's that? 38 ohms for the internal resistance, Ri, 38 ohms. Well, that pretty much exactly matches the 35 ohms on this piece of paper here. 35 ohms, and I've got 38 ohms. Wow. So it would seem that these zinc carbon or possibly zinc chloride, I have not seen any information on zinc chloride, so we'll assume that these are zinc carbon. It seems that these zinc carbon batteries, now I'm not sure that this meter here, my little watt meter, draws 200 milliamps. It probably doesn't draw anything like that, but it just seems that their internal resistance is so high, 35 ohms, that they very quickly drop down to a voltage where this Arduino isn't going to be happy. It's probably not going to be happy much below about 6.5 volts, and then this thing just locks up. So really it's not a problem with capacity, it's a problem with internal resistance. These just aren't suited to high drain applications. In fact, they're only really suited to ultra low drain applications, like something like smoke alarms. But then would you really trust crappy 33p 3 in a pack pound shop batteries in your smoke alarms? I'd far rather stick an alkaline in there when your very life depends on it. So I don't really see that these things have an application anywhere really. So certainly I'm not going to be buying any more of these pound shop 9-volt batteries. So for my experiments where I'm using these milliamp meters or watt meters, I'm certainly only going to be using either the nickel metal hydride or the alkaline, which under a moderately heavy load, their voltage stays up. I'm not going to use the zinc carbons. It would be useful actually to know how many milliamps this watt meter draws. Perhaps I'll build another one, make it a milliamp meter, and actually measure that. Oh yes, and the other thing I must remember is to go and reconnect my solar panel outside. Cheerio.